Hello, Algebra 1. Today we're going to be looking at application problems for polynomials. And what we're going to focus on in particular are rectangles. So we need to review perimeter and area. So how do you find the perimeter of a shape? Well, yeah, you add up all the sides. It's like walking around the object. But then to find the area, that's going to be square units. And what you do for a rectangle is you multiply the length times the width. So we're going to be using those two ideas today to find perimeter, add up all the sides, to find the area, length times width. But first things first, what we need to do is we need to add some right angles into this shape, because it is in fact a rectangle. Rectangles are equiangular, and something else we know about rectangles is opposite sides are congruent. So if this is 6x plus 9, we could write this as 6x plus 9 as well. And if that's 4x minus 1, the opposite side is 4x minus 1 as well. So class, they're wanting us to find the perimeter and the area. Well, the perimeter, we could do that a few ways. One way you could do it is you could take 6x plus 9 and double it to account for both. 4x minus 1 and double it to account for both, and then add them together. Or I kind of think it would be a good idea, since perimeter is equal to adding all sides, we could just find the perimeter directly by combining like terms. So we've got a 6x, a 4x, that's 10x. We got another 6x and 4x, that's 10x. Together we've got 20 x's. And then we can combine the constants and get, let's see, so that would be 8 and 8, so 16. And we found the perimeter right away. Now we still need to find the areas. So area, as I was saying earlier, is length times width. And our length and width, it doesn't matter which one is which, but we've got a 6x plus 9. We're going to multiply that with the 4x minus 1. And we're going to get to distribute it. Distribute the 6x to both the 4x minus 1. So we get 24x squared minus 6x. Then we distribute the 9. We get 36x minus 9. And we're almost done. We get to combine like terms in the middle to finish this out. So our area is equal to 24x squared plus 30x minus 9. So perimeter and area, that's what we're looking at today. What do you guys think? Let's go ahead and move on to some other sort of situations that we might encounter. So for this next example, it says find the area of the shaded region. And again, class, what you got is a rectangle. So I'm going to add some 90-degree angles in here to show it's a rectangle. And on a problem like this where it's not so straightforward, let me zoom in a little bit more so you guys can see that better. Sorry. So yeah, it's a rectangles all the way around. But think of a game plan. What are you going to do to figure out the area of the shaded region? What would be a smart way to approach this? And then once you figured out your approach, you can go ahead and set it into action and start writing things out. But how do you think would be a good way to find just the shaded area of this figure? And yeah, so I think eventually you might come across the idea that what you could do is you could find the area of the whole shape and find the area of the small rectangle and subtract them. And that would be a good approach to this. And I would describe that as we're going to find area of the big minus area of the little. Big minus little. But you do have to be careful here, okay? Because see that subtraction? We're going to have to subtract whatever polynomial we get for the area of the little. So we want to be careful to actually subtract the polynomial, not just one of its terms. So to get the area of the big, let's go 2x plus 3 times, so length times width, 4x minus 5, and let's go ahead and figure that out. Distribute the 2x. 2x times 4x is 8x squared. 2x times negative 5, negative 10x. Distribute the 3. We get a 12x, and then a minus 15. Let's go ahead and combine like terms in the middle. So we've got 8x squared plus 2x minus 15. So this was big. Now let's calculate the area of the little. Little, we're going to have 3x plus 2 times x minus 8. Distribute. Distribute. And then in the middle, you can combine like terms right there, and you'll get 3x squared minus 24x. I'm sorry, minus 22x minus 16. And now, class, what you got to do is you got to, I'm going to put parentheses around them because we are going to subtract them. And one thing we really need to be careful with subtraction is we got to make sure to distribute the negative. Or another way to think about it is we need to add the opposite. So we're going to add the opposite of this polynomial. So it's going to be negative 3x squared plus 22x plus 16. And then we're just combining like terms. And we're going to get the x squareds together first, get 5x squared. And then we'll combine the 2x and the 22x to make 24x. And finally, the negative 15 and the positive 16 make plus 1. And we found the polynomial that represents the area of the shaded region only. So class, just a reminder, when you're subtracting a polynomial, put parentheses around it so that you make sure to distribute your negative. Okay, well, if you guys are feeling good about that, let's flip it over to the back and see what else is going on. Okay, so on the back, we've got a perimeter given to us. So this is interesting. We've got a perimeter given to us, but they want us to find the missing side. Okay, so class, I usually like to write equations, but we haven't solved polynomial equations yet. So I'm not going to go that route. I'm just going to have to think through this. The perimeter is the sum of all the sides. Okay, so here's the thing. I think to find this missing side, a good approach would be to take the perimeter and subtract both of these polynomials from it. And the result would have to be my missing side. Now there's a couple ways we could write that. We could write this polynomial out minus that polynomial minus that polynomial. But I think maybe a more clever way to do it would be to add these two together, then subtract it. I think that might be a little easier approach. So I'm going to go that route. I'm going to go find the polynomial that's these two sides together. So we'll combine like terms. There's no x to the thirds to combine, so we just have 2x to the third. The 2x squared and the x squared combine to make 3x squared. I'll just kind of knock these off as we go along. And then the 7x and the minus 4x becomes a 3x. And finally, the 6 and the negative 8, we get minus 2. Okay, so that's those two together. Now our game plan is to take our perimeter and subtract this polynomial from it. So I'm going to write out perimeter is 2x to the third plus 4x squared plus 6x plus 3 minus our polynomial here, 2x to the third plus 3x squared plus 3x minus 2. Now class, we've got a lot of terms going on here, so we just want to be really conscientious, really careful, really deliberate about our steps, because we don't want to miss like a negative or something and throw this all off or askew. So when we subtract, I like to think of it as adding the opposite. And then combine like terms. The 2x to the thirds, because one of them is negative, they eliminate, they're gone. And then we'll move on to the x squareds. It looks like we'll have one of them left. We combine the x's together and it looks like we'll have, so be careful, that's 6x minus 3x is 3x. And finally our constants will combine to make 5. And class, we found the missing side. Just like so. So hopefully that made sense. You could have gone about this differently, but I like the way we went about it. Combine these two, combine these two together and then subtract it from the perimeter to get the missing side. I think that worked out pretty nice. Okay, we've got one more, I believe, so let's take a look. All right, I think I've got most of that in the screen there. So example 4, the area in square units of a rectangle is represented by 6x to the third minus 2x squared plus 4x. If the width in units is 2x, what is the length in units? All right, well class, I could draw a picture here, but I'm not gonna draw a picture. But what's kind of interesting is they give us the area. They want us to find the length. Well, recall that the area formula is length times width. I think this is going to help us to determine our course of action. If we want to find the length, we would need to get rid of this w by dividing it. So that instructs us as to what we're going to do here. We're going to take the area and divide it by the width. And we're in luck because our width is a monomial and we've actually learned how to do that. So let's take 6x to the third minus 2x squared plus 4x, take that polynomial, and we're going to divide it by a 2x. Now class, the way I taught dividing by a monomial is you distribute the division. You distribute the division. So you're going to divide this first term by 2x, the second term by 2x, and the third term by 2x. You're going to distribute the division. And when you do that, you divide the coefficients. But for the variables, you can subtract the exponents. The division property of exponents is you can subtract them. Another way that people think of it is you've got x times x up top, you've got an x on the bottom, it's going to cancel one of them out, and you're left with 2. Whoops, that was weird. You're left with 2. And then for the next one, the 2's divide out, and if you got x squared divided by x, you've got 1x left over. And back here, the x's are gone. They eliminate, they divide out. But 4 divided by 2 is 2. And we found our length, just like so. Thank you for watching.